This is a series on C for embedded systems. In this video, let's learn unions in C programming. A union in C is a user-defined data type that allows you to store different types of data in the same memory location. This is very important. It'll allow us to store different types of data in the same memory location. So in structures, each member has its own memory space, but in a union, all members share the same memory space. The size of a union is determined by the size of its largest member. But in structures, each member will take its own memory and will have size is basically sum of all the member variables. So here, the size of union is determined by size of its largest member. So let's look at this with an example. So in this example, I have defined a union called data, which has a type integer, and name of the integer is int value, and name of the integer variable is int value, and we have a floating type variable called float value, and we have a string of an array of characters. So it's a string value of size 20. So we know that int value takes 32-bit, float value takes 64-bit, of course, it's based on architecture, and the character string or the string we have defined as a 20 bytes. Okay, so let's just look at how to use this and how it works. So in the main, I've declared a variable called data and then of type data. The size of the union is the largest member. So okay, let's execute this and let's compile this and execute and see what happens. So gcc union.cif and a.exe. Let's execute it. Okay, so here you can see that we have got the output. So the first print says the size is 20. You see, we just now understood that size of a union is the size of its largest member. So in our case, size of the largest member, the string is 20 bytes. So you can see size is 20. Okay. Now let's look at assignment values to members, assigning values to members. So in this example, what we see is the data union has three members. Like I said, int as an integer, a float, and an array of characters. The program declares an instance of each union named data. Okay, that's what we've seen. Values are assigned to each member of the union. The program prints the values. So let's look at it. Here, the data.int value I assign 42 and then we print it and it works fine. And here I assign the data value for the float and we just print the data of the float value. Now let's look at this. See, the union shares the same memory space, so int value is now overwritten by the float value. Now, after we assign the value to float, we try to print it. You see, int value after float value assignment is basically this big number. So what is this big number, right? So you can see that the floating point representation of the value in the uh, in that memory location is 1078523331. So that's the understanding. So let me explain you this a little bit. So for example, the way it works is you have a union. Okay, union has, this is the memory space allocated for the union. Okay, so it has say integer it has float, and it has a string or an array of characters. So what happens is when an integer is defined, it will take, let's say, 4 bytes, and when a float is defined, it'll take 8 bytes, and for a character, we know that it is basically 20 bytes. Okay, so and it actually shares the same memory space for all those different variables, the members. Okay, so what happens is the int value after the float value assignment is this number, which is the decimal value of binary representation. So this is the value. I basically calculated it. Of course, we get the online converters. A float value 3.14 stored in memory. So that is why you see this number. Okay. And after this, we basically store, we copy this string to this string. So we use str copy. I'll cover this later in the video series. Well, see, the data string value is now assigned with hello union. I just print it. You can see that string value is hello union, and let's do access the int value after the string assignment. You see, again the number is changed. Okay, so this is basically, I think, as you guessed it, it is the string value assignment, which is the decimal value of binary representation of first 4 bytes of hello union, so in memory. So basically, this is the value that will be stored, the hexadecimal, in this memory, the first 4 bytes, and this value is will be accessed for the integer. So I hope this is clear. So that's why we need to be very cautious when we use unions. So the key points are, unions allows us to store different types of data in the same memory location. So when you modify one member of the union, other members may contain unpredictable or garbage value. I would not say garbage, so it's an unpredictable value which doesn't make sense for an integer or a float value when you store a string. So that's basically. So in this example, modifying float value affected the value of int value. So as expected. The unions are useful when you need to save memory by using the same memory space for different types of data, and you know at any given time which type of data is stored. So be cautious when using unions, especially when modifying one member and then accessing another, as this can lead to unpredictable behavior. Well, as we see that, let's say if you want to store a float and you access the integer, the behavior is entirely different. The unions are powerful but should be used carefully to avoid unintended consequences. They're commonly used in scenarios where memory efficiency is crucial, such as in embedded systems or when interfacing with the hardware. So, but in general, we don't use much of a union, but the knowing this concept is important. Sometimes we use it, but use it very cautiously. So that's about unions. Thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.